Today, we're going to crack a code. But nope, this isn't about secret spy messages. It's about learning the secret language of the universe, algebra. It's a language that turns messy, everyday words into pure, precise logic.
That's right, you heard me. I want you to think of algebra as a language. It's got its own vocabulary, its own grammar, and once you get fluent, you can translate really complex problems into simple, elegant solutions.
So, let's just reframe our whole approach for a minute. What if math isn't just a list of problems you have to solve? What if algebra is actually a language you can learn, a tool for thinking with perfect clarity? Kind of cool, right?
Okay, so like any language you'd learn, you have to start with the basic grammar and vocabulary. So that's exactly what we're going to do. Let's build our own little algebraic dictionary, one word at a time.
First up, the variable. You've definitely seen these before. Think of this as the noun of our new language. It's just a placeholder, usually a letter like X or N, that stands in for a number we don't know yet. It's the who or the what in our mathematical sentences. Now, every variable has something called a domain. Don't let the fancy word fool you, it's just the set of numbers that the variable is allowed to be. For example, if C represents the number of cookies in a jar, its domain is whole numbers. Why? Well, you can't have half a cookie or a negative cookie.
And when you combine these variables with numbers, you create an algebraic expression. This is basically our version of a phrase or a sentence. Something like 25 times n, for instance, is an expression. It's describing a relationship.
So, now that we've got our basic grammar down, let's get to the fun part, the translation. Think of this as our guide for turning everyday English words into the clean, precise language of algebra.
Let's begin with a classic, addition. You know, in English, there are tons of ways to talk about adding things together, but in algebra, there's just one, beautifully simple symbol.
Now check this out. It's pretty wild how many different phrases all mean the exact same thing. Whether you hear the sum of A and B or B more than A, the algebraic translation is always just A plus B. This is our first real taste of how powerful algebra is at simplifying things.
Next up is subtraction. And okay, this is where our new language gets a little bit tricky. Unlike with addition, when you're subtracting, the order of the words matters a lot.
So the crucial thing to see here are phrases like B subtracted from A or B less than A. Did you notice how the order is flipped? B less than A doesn't mean B minus A, it means you start with A and then you take B away from it. That's a classic trip-up, so definitely keep an eye out for it.
All right, on to multiplication. We have a few ways to show this in algebra, and for a really simple reason. The standard times sign, times, looks way too much like the variable x. It gets confusing fast, so we needed a better way.
You might see a raised dot, but the most common way, by far, is to use no symbol at all. Just writing two variables side by side, like AB, is the cleanest way to show multiplication in algebra. It means A times B. Simple and zero confusion. And that brings us to the last of the big four, division. And just like with the others, English has a few ways of saying it, but algebra just streamlines the whole thing. While that classic division symbol works, you will almost always see division written as a fraction, A over B. It's just way more versatile for more complex equations down the road. So if you hear the phrase, the quotient of A and B, that's your signal to write it as a fraction.
All right, so there you have it. That's the basic translation guide, a dictionary for addition, subtraction, multiplication, and division. Now let's put it into practice and test out your new fluency.
Let's start with a simple one. How would you translate this? W is more than 3. Go on, take a second. How would you write that in the language of algebra? Did you get it? The most direct translation is 3 plus W. That phrase, more than 3, tells us that 3 is our starting point. Now, even though W plus 3 gives you the same result, this is a more literal translation of the words, so well done.
Okay, ready to level up a little? How about this one? The sum of T and U divided by 6. This one has 2 steps. Take your time. How would you translate that entire phrase?
The answer is T plus U over 6. The real key here is that phrase, the sum of. It tells you that T plus U is a single group, a package deal, that has to be calculated first. We use parentheses, or in this case, the fraction bar itself acts as the grouping symbol to show that. See? This is how algebra handles multiple steps with perfect clarity.
So you might be wondering, why does any of this matter? Well, it all comes down to one single thing,
precision. Our everyday language can be messy and ambiguous, but algebra is designed to be crystal clear.
This slide shows you exactly what I'm talking about. The phrase on the left, the product of x and y, comma, decreased by 2, is clear. You find the product xy first, then you subtract 2. But take out that tiny comma and the meaning completely changes. It could now mean x times the quantity y minus 2. One little piece of punctuation, two totally different outcomes.
And that's really the key takeaway here. In English, we use punctuation, like a comma, to create clarity. In algebra, the symbols themselves, the parentheses, the fraction bar, they do that exact same job. They remove all the doubt and make sure the meaning is universal and precise.
So you've just learned the grammar of an incredibly powerful new language. One that builds bridges, sends rockets into space, and powers the phone in your hand. The only question left is, what will you use it to understand?